and getting me on board. The reason being, I am not the best when it comes to scheduling, as people who have worked with me already know. So they've put in a lot of effort for getting this thing going, and despite all the glitches with the platform and with other stuff, they've been braving through it all. So I think they deserve a kudos. And that's where I'm going to start with. But I also have slides to share, because what is a workshop or a webinar without slides? So I'm gonna get started with the slides. First, it's gonna be inception when you're gonna see my screen, because you're gonna see yourselves. So yes, I hope you can see my slides right now. Somebody can confirm, because I can't see your faces
Yes,
right now. Okay.
yes, yes, yeah.
All right.
Screen is visible.
All right. So, hello everyone. We're gonna talk about WebAssembly today, and I know that a lot of y'all probably know me, but I'm still gonna introduce myself. I'm Divya Mohan, and I'm a principal technology advocate at SUSE. It's taking me time to say that because I'm not used to that word right now. We've changed the titles a little bit. Um, but over and above that, outside of my day job, I'm a contributor and a docs maintainer to Kubernetes and the wider CNCF ecosystem. I'm also leading the efforts around the Chaos Asia chapter. We're relaunching it in the upcoming week, and I'm doing um, the co-leading effort for that, along with other few people. And contextually, like more relevant to the topic of this discussion, I'm also a recognized contributor, albeit a recent one, to the Bytecode Alliance. Now, the Bytecode Alliance is one of the organizations that actually works with WebAssembly, and it tries to maintain and create standards around the WebAssembly ecosystems, along with W3C and CNCF and some other organizations in this space. So, I typically start off by talking about the why. But today I'm not going to talk about the why. I'm going to talk about the what first. The reason is, pretty much everyone here has heard of the term WebAssembly in some form or the other, across conferences, across webinars, across sessions, wherever. So I know that you all know a little bit, or you all might have heard it in passing, and I want to first shed on first shed a light on what exactly WebAssembly is. Now, to do that, we're going to look at a super brief. This does not cover extensively or comprehensively what's happened in the WebAssembly ecosystem ever since it was announced in 2015. But what I want to highlight here is what's in production today is still the V1 version of the specification that was announced in 2017. The V2 draft was announced in 2022, but it's just a draft. It's still work in progress. And the other two milestones we shall get to shortly. But what exactly is this V1 MVP that I'm talking about, and what is the specification exactly doing? So, WebAssembly, essentially, the specification boils down to it defining the technology in the form of a bytecode or a binary instruction format. This is designed to be a compilation target, so it's not exactly, I wouldn't call it the highest level of programming languages like Java or maybe C++ or something else. It's comparatively lower level, so it's designed to be the output of a compiler, or it's designed to be a compilation target, which is why it's also designed to be portable across architectures and languages. Now, we'll see all of this in greater detail in the coming few slides, but the definition also specifies that this the fundamental unit of a WebAssembly program is a module, and that module is essentially sandbox. Now, sandbox means that it's isolated from its host environment, and there's no way the module or the program can actually reach out to the host environment. It's just there, and unless you have like surrounding features like the WASI proposal I talked about. There's no actual way for it to contact the host environment. Now, the name is important because it's not just for the web, although it was initially started for the web. Uh, because of issues with JavaScript, with respect to more complicated applications that were being brought to the web. But it's found applications outside of the web as well, in the server side ecosystem and in other ecosystems as well. Also, just one last thing before we go ahead, it is W capitalized and ASM in small case, not the entire thing capitalized. People tend to make that mistake. I've made that mistake when I started out. So that's a bit about, what WebAssembly is per the definition and how it's commonly referred to in the ecosystem. But when I've been talking about this, I'm pretty sure a lot of you worked with Java. And when I've talked about the definition of WebAssembly being a compilation target, it sounds really similar to the Java bytecode in a JVM, right? Because even that is a compilation target. And if you're from the front end side of things, that actually is very similar to JavaScript. And um, WebAssembly is one of the you know f- is not one of the is the fourth language of the web officially, alongside JavaScript, HTML, and CSS. So this thing of slides is very very intentional, because neither Java nor JavaScript are polyglot compilation targets. In fact, the Java bytecode was not designed to be a compilation target at all, and the invoke dynamic opcode, which basically helps more dynamic languages like Jython, JRuby, Clojure, Scala, Groovy target the Java runtime. It was introduced as an afterthought. It was not designed or baked into the original opcode. I mean, original bytecode. Sorry. So both Java and JavaScript were not polyglot compilation targets, because they were, fully functional as a compilation target, but they were there and they were popular, and there was a community that actually supported the entry of multiple languages into the ecosystem, is why they became polyglot compilation targets. um and when we talk about things that are not designed to be something but they eventually take upon that functionality, there are going to be some pain points. And both jvm java and jvm and JavaScript actually do have these drawbacks. And that's why there was a need across the ecosystem for an intermediate representation, and that's where WebAssembly fits in. Now, when I said that WebAssembly was a compilation target, y'all might have wondered, okay, I'm not going to write it by hand, because I'm clearly not going to write bytecode. I'm clearly not interested in designing a compiler. So why should I learn about WebAssembly? First reason that I think about is there is an increased focus on using memory safe programming languages. And the reason is, when you're using memory unsafe programming languages, right? Um, what ends up happening is there are loopholes that the hackers and the people who exploit your software are easily able to maneuver, um, when you're using these particular unsafe programming languages. So there's been an increased focus towards the other side, wherein industry leaders have come together and have urged administrative offices across the globe to switch to memory safe programming. That's the first reason. Now, this is not to say that there's no memory safe programming language. Now, you also know, I also know that there's stuff like Go and Rust that's already there. But having an additional layer of security in the form of that WebAssembly sandbox, right? It couldn't hurt. And it basically also guarantees a second layer of security when you're using even these memory safe programming languages like Rust and Go. So that is this first point. The second point is I want to jog back to the previous couple of slides, right, where we spoke about WebAssembly's inception and the journey thereafter. So there were a lot of standards announced. Um, as you can see here, and it was not a lot of standards, it's just one standard, but there was a standard announced in 2019. Now the reason why this was announced in 2019 and not earlier is pretty simple. WebAssembly initially was targeted towards solving the challenges of the web. When people saw the benefits that it could bring, they started exploring whether it could actually take, whether we could actually take the benefits and, um, adapt it to the server side ecosystem and other ecosystems as well. Now, being a sandbox, it doesn't have access to network. It doesn't have access to the IO. It doesn't have access to clocks. It doesn't have access to a lot of things. And as a result, that sandbox, when you transfer it to the server side, it's basically not that useful. So that's why WASI as a standard was announced again as an afterthought, because of the applications that were there in the server side of things in 2019. And ever since then, a long time has passed, 5 years almost. The preview 2 was announced in January, I think January 26th or 25th, 2024. Now, why was there such a long hiatus of sorts? Is because um, we will explore this in the WASI section, but just to give you a brief um, idea, the WASI standard, when it was announced initially, it was announced to actually give all those capabilities that I spoke about: networking, file systems, basic capabilities that developers need. Um, uh, Developers, and by developers, I mean library developers, not like developers who do day to day development. Library developers need, right, when you are developing stuff. So, that was just there for that particular purpose. And then the whole goal of WebAssembly was to be a portable compilation target, and it's a mighty goal across architectures, across languages. It's a very mighty goal because there's a lot of work involved. And when we saw that goal and we saw the capabilities that we were trying to introduce, and we were trying to see what is the best way, we as a community had very divided opinions on how to proceed further. So there was a lot of consensus seeking, disagreements, discussions, after which there was a fork in the way things went. WASI Preview 2 is the standard that's being developed along with the W3C, which is in development along with W3C and Bytecode Alliance, sorry. And WASI X is another thing that's uh, you know an extension of the original WASI standard, and it's being developed by the folks at Wasm. So because the standard that's being developed is WASI Preview 2, we are going to focus on WASI Preview 2. And given this history, I think it's important to discuss, because all of this fits into where WebAssembly is going when it comes to the cloud native ecosystem as well, and outside of it. So that's the second reason why. The third reason is, when you talk about WebAssembly, you seem to hear a lot of applications in like um, browsers and outside of it. And even when you're talking about WASI, you're hearing a lot of component model stuff. You're hearing application binary interfaces and new things coming up. So I think it's necessary for people to gain clarity on what it is and where it's headed. And the best place to start is right at the beginning, the bytecode or the binary instruction format. So, how does that actually work? Now, when we talk about WebAssembly or any other code not even if we don't talk about WebAssembly, sorry, when we just talk about the programs that we write or the software that we write, the things that we write are not understandable to the computer. That is because we write in human readable and human writable English, or words that are actually recognizable to us and terms that are recognizable to us. The computer doesn't understand that gibberish. The computer basically understands 0 and 1, and strings of zeros and ones. So there is definitely a communication gap and a language barrier there. So I'm pretty proud of myself for thinking of the language barrier bit. But coming back, um, so you need somebody in between, a translator, to actually do the job of converting stuff into you know formats that are understandable by the computer. Because if I'm writing code, I want it to execute somewhere and produce some result. I'm not writing code because I'm free. I'm doing nothing and I want to write code. That's not why people write code. It has to serve some purpose. It's not art. So essentially, the compiler is the one that does the job of the translation. So what it does, it is takes the code and brings it to an intermediate representation, which then targets the various CPU architectures. I've just mentioned two, but there are obviously more CPU architectures that could have fitted on this slide. So that's how software execution and compiling works. But unfortunately, the intermediate representation across language libraries is non-standard. So that is because different libraries have different way of different libraries and languages have different ways of implementing things. So essentially there are three different types of intermediate representation based on how close they are to the um, machine code, that is the strings of zeros and ones that you can think of. So there's the low level IR, there's the mid IR, and there's the high level IR. So low level IR is the thing that's closest to an instruction set for a machine. The high level IR is something that is closest to your programming language. So you'd probably be able to understand the high level IR, but I don't think low level IR is something you would want to understand and read through. So when I'm talking about making that IR standardized and getting it to port across languages and architectures, it's not new. There have been several efforts across the years, and by years I do mean years. It starts as far back as Pascal's P code, which was in the 1970s. I'm pretty sure none of us were born then. So Pascal's P code is one of the first things I know of, but I'm pretty sure there were things before that as well. But then there are other efforts that have been there, like the native client, the portable native client by Google. There was IBM Stimmy, there was Asm.js, there's stuff like the Java bytecode and the JVM, which we discussed earlier, and there's JavaScript in the front end. So where does WebAssembly actually fit in all of this discussion that I spoke of? So essentially, your code, when it goes through a WebAssembly supported compiler, it gets converted to a Wasm module, which is the fundamental unit of WebAssembly. Now, that Wasm module can be run across hosts, and that host doesn't necessarily need to be a CPU. It can be a container, it can be a browser, it can be a runtime, a WebAssembly compatible runtime like Wasm time, or even the Node.js runtime. And of course, it does include CPUs and other uh, edge architectures that I could have possibly listed, but the slide was way too short. And when I'm saying all of this, you think, hey, hasn't already this been achieved with containerization? The answer is no, because containerization serves a different purpose. Now, what a container does is basically take your application, its utilities, and an underlying operating system, and it does this by using a layered snapshot of each of these, and it packages this into a container image. This container image is then taken by the container engine and pushed onto a container runtime wherein containers actually run. So um, containers abstract away the virtualization that's already there for the operating system. But WebAssembly doesn't exactly do that the same thing. WebAssembly is basically just dealing with the code that you write, taking it and building it into a WebAssembly module. Assembly module runs in a runtime, and that runtime has to be compatible with all the architectures, or it doesn't really need an architecture. Like I said, it could run in a browser, it could run in a container, it could run in on an edge architect, on an edge device. So it basically abstracts away different things. So containers and WebAssembly, they're not they do coexist, and they can coexist, and that's probably the way forward. But when I'm talking about even running all of this modules outside of the browser, for which the whole WASI standard was created, uh, why are we why did we create that? Because obviously when we started out, browsers were the only things that the WebAssembly module supported, and it was very cool. But then what happened is we needed it to go beyond the browser, and the WASI specification came in, which the TLDR version is, it's just a set of APIs, and it's been developed as a standard for the purpose of being implemented across these various ecosystems, by the WASI subgroup, which is a subgroup of the WebAssembly community group at the W3C level. So our aim with WASI, write once, run anywhere. I'm going to say that multiple times in case that doesn't get drilled in. And I'm going to take a pause there because I've offloaded a lot of information, and I've also spoken WASI so many times, but we've not really explored what a system interface is. So a system interface is basically something like, I think you can imagine it to be the door in your house, but obviously it's not the door to your house, it's the door to the underlying space underneath the kernel. So when you execute an application, or when you expect an application to retrieve data, read data, delete data, modify data, it cannot directly access all of that. It needs to go via the kernel through system calls, and that system, that barrier that is there, so that the applications cannot directly mess with the data, there is what's called as the system interface. So how does WASI actually propose to implement this system interface, right? Because the module is a sandboxed entity till you actually give it access to the outside world. So we need all those utilities to access these various features of the operating system, if I may. So it proposes to implement it via via the standard, wherein the first standard that's being developed is the WASI core, which gives like access to files, access to networking, IO streams, basic capabilities. And then, surrounding standards can be developed in tandem with this. That is the idea. But unfortunately, that did not work out with WASI Preview 1. Um, and by saying it did not work out, I'm not saying that it's not enough, but keeping in mind the end goal of WebAssembly, it's not really enough. So the WASI Preview 1, the APIs for these various utilities were heavily influenced by the POSIX standard and the Cloud API. Now, both of these are targeting Unix like operating systems. And if you're talking about portability, just targeting Unix like operating system seems very counterproductive, because you needed to target more and reduce the amount of efforts that it's going to take to develop this whole standard, right? So it did not make sense to do it. But we were trying to essentially provide those capabilities that I spoke about. We weren't trying to go um, beyond the curve and figure out how to do other stuff. So the challenges were that what came out of this entire effort um, didn't make sense for a lot of platforms, uh, because it was low on portability. So for Windows, there was a requirement of a compatibility layer like Sigbin, and for web embedding, sorry, it simply did not make sense. And of course, the ABI implementation for this was very monolithic, and that is in direct opposition to what we want WebAssembly to be, a modular plug and play thing which can actually work across languages and architectures. So monoliths and plug and play don't really go well together. And what landed as part of WASI Preview 1 support is support for clocks, random number generators, file systems, environment variables, standard IO, and error streams. So, not much, but it was sufficient to let developers do the bare minimum. And of course, there was, like I said, a lot of discussion and disagreements within the community. Then there were two forks chosen, and people decided to go either way. And what got standardized, or at least what is being standardized as of now, is WASI Preview 2. So WASI Preview 2, how is it different? Now, WASI Preview 2 is a set of APIs, again, influenced by the canonical ABI and the core WebAssembly spec. And the most important part here is it is not any longer a monolith. It's more modular, and it adheres to the component model, which makes this modularity possible. So, what are we trying to do with this is we are trying to push the boundaries of what we can achieve with WebAssembly. We're trying to make it like a whole thing of its own, where people just write code in a programming language of their choice, and it can interoperate with um, code written in other languages, and this should happen like extremely seamlessly. And that's what is the end goal of this. And towards this, we've introduced the concept of worlds in WASI Preview 2 or O.2, wherein it can be likened to the execution environment of the component, which is again the fundamental unit of a component model. And the two worlds that were introduced were the CLI world, which provides a CLI like execution environment, and the HTTP proxy world, which gives a WebAssembly module the ability to concurrently stream in and out any number of HTTP requests. And the APIs that were launched were IO, clocks, random file system, sockets. We have sockets now, CLI, and HTTP. And I just said component model, and I'm pretty sure you're wondering, hey, she did not really dive deep into that. And that is intentional, because I wanted to give you a sneak peek into what WASI Preview 2 is, and then actually discuss more on the component model. So it all again goes back to the WASM module, unfortunately or fortunately for you. So the WASM module that you get as the output of the compiler, assume that you are writing two assume that you as a developer writing one module, and your friend is writing another module, not module, right, programs. We're not talking in modules right now, we're talking in programs. So you're writing a program in, say, C++. I've written Rust here, but it could be anything. You're writing a program in C++, and somebody else is writing a program in Go or Rust or JavaScript. um so the compiler that you use, that will transform it to the WASM module. You'll expect that, since, hey, WASM module, you can talk to each other, right? And you can interoperate because it's all part of the same standard. But with WASI Preview 1, that was not possible. Why though? Because a module kind of looks like this. And I'm sorry for my extremely bad diagram skills. I am not Picasso, not even close to Picasso. So this is what a module looks like. And unfortunately, if you look at the textual description, you can see a lot of ins and floats here. And that's what the module primitives are ints and floats. So everything and anything that you describe in a higher level language comes down to ints and floats in WebAssembly. And each language has a different way of actually, compiling it or representing it in ints and floats, because again, not standardized IR. So they are not interchangeable. So what this zoomed in conversation would look like is, if the WASM module actually says this is a string, WASM module 2 might not really recognize that as a string, because the representations are different. And that is why the component model was designed as like a shared dictionary, wherein the component provides a wrapper around the core WASM module, and the richer types like strings and structs and other stuff are defined using WIT, which is one of the I want to say languages that it is that the entire VASI preview 2 is defined in. And this you know uh, how do I say it? This is translated to bits and bytes using the application canonical application binary interface. So the component ends up looking like this. Like, you essentially have a plug and play thing going on when you describe a component. So it defines imports and exports, and allows the core WASM module to have like an entire definition. And you can sort of, define these globally and let the Go module plug and play into the Rust program or reverse. But this is easier said than done, right? And how does this all fit into the cloud native context? Because this still doesn't make sense. How is this all affecting cloud native? So, when we talk about hosts, right, I said that we could run in containers. And I think y'all deserve to see a demo of how it actually does. And this is super secret. And y'all are probably privy to the first demo of this on Rancher Desktop. So hopefully, I'm going to be able to share that. Just a second. I am just gonna see if this works. Just a second. So just terminate. I'm gonna start a new shell, and let's zoom this in a little bit for y'all. And so I've just compiled this from source. This is not live yet, but it will be live in the coming not months, sorry, weeks, in the next version, that is. So I'm just gonna yarn dev it from here and a bit of time. But you is essentially a WebAssembly runtime embedded inside the container or the pod within Kubernetes. And I'm gonna request, I'm gonna issue a call request to that runtime. Gonna give me a hello world in response. I hope that happens. Okay, so let's just go here. And right now, the thing is, I don't remember the um just a second. I've done this a couple of times. So I have these manifests stored on this in this repo. Y'all can access it. There is links and worry at the end. But I'm essentially going to apply this manifest, which is basically going to spin up, no puns intended, spin up a deployment with pods running the spin runtime. Now, spin is an open source runtime developed, a WASM runtime that's sort of developed by not Wasm runtime. It's developed. It's WebAssembly related, but it underlying it uses Wasm time, and it essentially allows you to run WebAssembly workloads. And how we're doing this is because we have a container D shim. Container D is one of the container runtimes, and we have a shim that runs, that allows Kubernetes in K3s to actually run these as separate modules or as runtimes within the pod. So I'm just going to apply this manifest. You can check out the manifest later on. So hopefully, yes, all of this gets created. And let's check if the pods are up. They should be up super soon because WebAssembly is extremely lightweight. And as you can see, this is up right now. Now I'm going to issue a curl command. Again, I'm going to jog back because I'm very lazy that way. So if you can see here, there is a hello world that comes in from spin. We get a response to the curl command that we issued, and we've deployed a hello world app written in Rust on spin, right? So that runtime actually does work on in a Kubernetes pod. So whatever I've been saying till now actually does makes some sort of sense to you. Hopefully, that WebAssembly can run irrespective of wherever it is. It just needs a runtime around it. Can be on a container, can be on an edge device, can be in a browser, can be in a supported runtime like Node.js or even Spin or Wasm time, stuff like that. Okay. So that's the short live demo that I had, which worked, thank God. And why should you care? Because this was a big info dump that I just pushed on you. So why should you care about all of this? So right ones run anywhere. That's obviously there. I'm going to push that as an agenda. But imagine this: um, you're writing something in one programming language, and some other team needs that same functionality in another programming language because they develop programs in another language. And you don't need to rewrite the whole code again because you have this concept of a Wasm module. What if that actually became a reality? What if this interoperability became possible and we were able to reuse code? Not only does it mean lesser man hours, but imagine the amount of time that we would save and the efforts that we would save with respect to CPU cycles as well. So not only is it less compute intensive, but it's also greener way of doing software engineering. But that's a lot of work. And like I said, there's lots to do across the ecosystem. And it's not like, we're gonna stop anytime soon because we've just launched watch Vazi preview 2. We have to do we have to get out other iterations of stable releases, other improvements till the next actual major iteration comes in, which is Vazi preview 3. So there's a lot to be done, and you can actually help out, like if you're interested in contributing or if you're interested in actually working on developing the standard in your own way. You pick your fight, you pick your battle, pick libraries if you want to work with libraries, or you're interested in runtimes and tool chains and helping developers better their experience when it comes to WebAssembly, or you are targeting very niche integrations with other ecosystem like for example, cloud native and WebAssembly have a niche integration and it's making inroads. Like containerd is one example, CRIO is another. Then you have things like Envoy proxy, Kube Warden that are doing things in cloud native. There's also fantastic stuff being done by Fermion in the serverless side of things. Then there's also cloud native projects like Wasm Cloud. Lists are endless when it comes to ecosystem integrations. And if you're more of a front end person, the browser side is best because there also we need a lot of help. And if this all seems like too much, there's always help we need with bettering our documentation and in getting more people interested, because it's people that make tech, not the reverse. till now at least. So we need people to do this, and we need people to spread the word. We need people to actually talk about this a little more, spread awareness around it, so that more people understand and are not either hesitant to try out this technology, or they just like think of it as a new buzzword, because technologies can become buzzwords, and they do, and then the hype around them sort of gives people false expectations, and then it all gets really weird, because expectations are the worst when it comes to technology. You expect it to do something and it doesn't do it, and then you're like, hey, why is it not doing this? So a lot of it is open source, so there are ways you can help, and great starting points are listed here. Now this slide will be available on GitHub after the presentation, so you can directly click the links. But a few good mentions are the uh, Wasm working group on the CNCF Slack, the Bytecode Alliance Zulip chat, the WebAssembly Discord server where people across the ecosystem hang out, by the way, and the GitHub for Bytecode Alliance. So these are good places to start with, and like I said, these are all resources and of what I used when preparing this presentation. So this is an inexhaustive list, and you can find me here. For those who already know, who don't know me, you can find me here. And I think that's it from my side. I've been speaking for 40 odd minutes, and y'all probably, if y'all have not slept off, I wouldn't mind answering some questions.
Yeah, I think feel free to unmute yourself, probably switch on your videos and interact with everyone. So ask any questions if you have. Uh, so I think I'm just looking into the chart, Divya.
Hmm.
There is a question from Kelvin. What's the difference between Wasm and Wasm Edge?
So WASM is the standard, and WASM Edge is the runtime. So what is it's similar to asking what's the difference between containers and container D. So what is the difference is that container is the thing that runs in container D. Container is a standard. It's like OCI containers are a standard, an entity in themselves. So WebAssembly is the standard. Wasm Edge is the implementation of that standard with the as a runtime. So there are tool chains and runtimes, and Wasm Edge is one of them. I hope that made sense. So you'll execute, like Shivai said, you'll execute your WebAssembly module inside a runtime. Like I showed, like you have those different runtimes, right? Like you need a runtime to execute anything. You need a runtime even if you're executing your Java program, your Go program, your anything, and you need that. So Wasm Edge, all of these are runtimes.
Yeah. So yeah, there is another question. How do we integrate with serverless? Any existing support available?
Oh yes, like I said, the folks over at Fermion are doing work in this regard. So you should definitely check their work out, because there is integration with serverless and AI in their projects that they are working with, and I think that would provide you better context. So I can link it here if you want. Um, I will just give me a moment, but that is essentially the answer. Like, I am not going to claim that I know a lot about serverless or AI because I don't. I know stuff about WebAssembly, and I'm going to claim that that's my expertise. But serverless and AI and all of that, there are implementations there. And Fermion is one of those companies that's doing a lot of work in this regard. So you should probably check that out. So yeah, like just let me give that to you.
Yeah. So
This is the one. I
cool.
I hope that's there in the chat. Yeah.
Yeah. Thank you so much, Divya. So there is another question. So what about the security aspects? It's under at client browser with Wasm.
So yeah, that's exactly what I was saying, right? So the WebAssembly module is executed. at the client browser only. It's not so the browser is like the runtime. It's one of the runtimes that supports WebAssembly. So a Wasm module in itself is sandboxed, and that means that unless you explicitly write code that is malicious in nature, it's very difficult for the module to um, attack it or perform any malicious activities. Even with that, it's pretty difficult. Like even if you explicitly try to do it, so the sandbox nature is what protects it, and the browser is one of the runtimes where the WebAssembly module actually runs. So without um, you know, explicit exports and imports being made, there is no way that a malicious attacker can actually uh, hinder the execution or maneuver your code or inject attacks like they do in the code nowadays. And I'm not saying that it's across all code bases, but some legacy code bases still do have that problem wherein you can inject attacks from the browser. With WebAssembly, it's significantly more difficult because of the sandbox nature of the fundamental unit that it's working with.
Yeah. Okay. So there is another question. With the Wasm importing other Wasm modules into code, doesn't the sort of seem like a binary blob thing, or will one have to compile it at least once?
So I think what you're trying to say is if you're trying to import WebAssembly modules into other WebAssembly modules, or am I getting that wrong? I just want to clarify. Yeah. So essentially, that is not what I meant by that diagram. Just putting that out there. I did not mean that by the diagram. So what I'm trying to say is you're going to have say one code one set of programs written in one language, and you need some functionality from there to be actually imported into another program, and that gets actually taken as a wasm module. So like you could have written separate blobs, binary blobs of this separate programs rather, or separate functions that get compiled into these different binary blobs, and that binary blob can actually be taken and imported into the program code, and that's what we're aiming for, like the composability of the wasm module into existing code. JavaScript does this very well right now, and there's a whole talk where Guy Bedford demonstrates this whole interleaving of two disparate ecosystems, which like the Rust and the Jco not Rust actually. Yeah, I think it's a Rust code and a JavaScript code, and he how it can be like the JavaScript code can be converted into a module and can be imported into the Rust code. So it's not blob into blob and a whole blob again recompiled. That's not what it is. It is basically just importing the module and then then using that functionality that is by that module in that program, rather than rewriting the whole functionality again in another programming language. I don't know if it made sense, but please let me know. And I will also try to find out the talk that Guy Bedford gave. But it's very difficult to find it because like he's given so many talks about this. So I will try to find that talk and I'll let you know.
Yeah. So there is another question from Kelvin. So Docker and Wasm are the same because they both are isolated.
That's a very good question. Um, but no, they're not the same. Because I covered that in the presentation. Docker abstracts your operating system. So it basically takes what you had with your VMs and your virtualization, and it abstracts that layer away. Now, what WebAssembly does is it just takes your code, right? And it compiles it into an intermediate representation that can not only be ported into different languages but also different architectures. Now, for example, as far as I know, containers cannot run in browsers. At least I've not seen a Docker container run in a browser. I have not seen a container run inside another container. I have not seen that. Could be possible, but I've not seen that yet. So, Wasm is able to do that because Wasm has its own runtime, and that runtime is the thing that's important to function across hosts and across um, the various architectures. Now, containers, they need a CPU and a host operating system to work with. I am not saying that this doesn't, but it doesn't necessarily need, like, it doesn't have a dependency on the fact that the operating system must be a particular way, and the architecture must be this, so I have to write something for this. So your Docker containers are basically tied into your operating system and are abstracting away your operating system, while your Wasm module is essentially abstracting away that intermediate representation that comes out of a compiler. There are two different abstractions at point here. They are targeting the same thing, that is, write once, run anywhere, and isolation, but Wasm has the clear benefits because of the way it's designed and the security sandbox features that it offers. So it has portability just like containers. It has isolation just like containers, but it's not a container because it's closer to a stack. It's actually a definition for a stack-based virtual machine as opposed to a container. I I don't know if it cleared this, but that's how I conceptualize it in my mind. But if you need, you can let me know.
Yeah.
I can explain further.
Yeah, thank you so much, Divya. So there is one last question I would like to ask. So you've been
Hmm.
leading the Kubernetes documentation project. And you're doing an amazing job in cloud native community. So what are the
Hmm.
suggestions that you give for newcomers, like to the audience? They want to get started with open source or getting to learn more about cloud native. Yeah, your suggestions will be valuable for them.
Yeah, that's a very good question, and thank you for asking. So, the first thing is that you have to, like I said, even at the end, right, of this presentation, you got to pick the area that you want to work with. Like, not everybody is proficient in everything. I am, for example, not the best at software development, as is probably evident. But I'm trying to get better. Do not write as much code as I'd like to, but trying to get better at it. But everybody has their skills and everybody has their strong points. Like some people are intuitively better at tinkering with hardware and software and tech. Some people are inherently better at dealing with people, organizing communities, organizing out stuff. Some people are better at writing. Some people might have a combination of these skill sets. So you assess for yourself as to what at when you're trying to start contributing to anything, and then based on that, see which projects are there which require help. That's what has helped me. I have not done like a whole lot of coding in my life, I can assure you all of that. But I can the reason that I'm the docs co-chair, I believe, at least, is because I was willing to go down the rabbit hole of exploring Kubernetes and understanding what were the pain points around the documentation. Now, documentation is something I'm good at because I like writing. I am writing a book, so I like writing. So that's one of my strong points. Similarly, community is another of my strong points. So I work well with these areas, and that's exactly what I try to do. And that's the thing. Like, I would suggest that assess your strong points and communities that you want to work with, because at the end of the day, everybody wants help. You got to pick out what you want to help with. Like, you could be good at a lot of things, and that's not probably what a community needs. They need probably something else. You have to search out communities that actually need the kind of things that you need, that you are ready to offer. Sorry.
Yeah. Yeah, thank you so much, Divya. I mean, like today, I personally learned a lot of things. So I become an audience, and
I'm glad you did. I am.
yeah. So yeah, we are very happy to see a lot of people joining and learn about Wasm today. We also recorded the session. We'll be posting the session in our LinkedIn and Twitter channels. So yeah, keep supporting women in cloud native. So we are trying our best to to be able to gather everyone and just get you into the cloud native ecosystem. And I want to see more and more women into here, and Divya is one of such inspiration to all of us. So yeah, thank you so much, everyone. And today, spending time with you is all amazing. And I should personally thank Divya for, for such a wonderful session, and to be able to talk with the audience of Women in Cloud Native.
Thank you so much, and I hope you'll gain something, if not everything. I tend to confuse people, so I hope it made sense, or at least made a little bit of sense to most of you.
Yeah, thank you so much. It was wonderful, and so we are very happy to host you for sure. Yeah,
Thank you so much, and have a great weekend, everyone.
yeah. Thank you. I'm just stopping the recording. Yeah.
Yeah.